Hello everyone, I hope you are doing very well. So welcome to this class. Today we are going to discuss the NCERT exercise of this chapter that is very important according to exam point of view, and it is very important in our daily life as well, right? And this chapter is acids, bases and salts, right? So you can see here, if I will say acids, comma bases and salts. I know you are aware about what are acids, what are bases and what are salts, but I want to introduce the topics, right? I want to give a overview. I want to summarize the entire chapter. Then we will start with the practice of questions. That means we will start with NCERT exercise. So in this chapter, first of all, how can we identify which one is acid, which one is base and which one is salt? First of all, we need to know which one is acid, which one is base and which one is salt. So some visual indicators are there. So you know very well. First of all, in this chapter, we have learned what are indicators. So, you know very well, indicators are those substances which can identify, which can indicate whether the substance is acidic, basic, or neutral or salt. Indicators are like of two types: visual indicators and olfactory indicators. Visual indicators which will show the color change when comes in contact with any acid, base, or salt, and which will show the smell change is like olfactory indicators. Olfactory indicators like you can see clove oil, vanilla, onion extract, etc. Visual indicators are also categorized like natural indicators and synthetic indicators. In natural indicators, like you can take what red cabbage, you can take turmeric, right? Turmeric in presence of bases becomes red, yellow to red, but in presence of acids it remains yellow. Like some synthetic indicators like methyl orange, like phenolphthalein. So about these indicators, their color change you know very well. Then after indicators, what are acids? Acids are those substances which will release H positive in the presence of water, you know very well. So due to the presence of this S positive, we can say these are acids. This substance is an acid. But if we know acids, listen me very carefully. If we know acids, so HCl is an acid, right? Because it will release H positive in presence of water. But if I will say dry HCl, it will be an acid or not? No, because dry HCl means no ions, no H positive, no Cl negative is there. So if no H positive, so no acidic nature. Okay. Then types of acids like strong acids and weak acid, which will dissociate completely in presence of water. Strong acid, which will not dissociate completely, which will dissociate partially in presence of water, are known as weak acids. Weak acids like CS3, COOH, methanoic acid, ethanoic acid, and like in natural acids like tartaric acid, etc. And you can take what strong acids like H2SO4, HNO3, HCl, etc. Then properties of acids, reactions of acids with metals and with other substances. Then we had done with the bases. Bases are what? Some properties are there of acids and bases, like bases are bitter in taste, right? pH, you know very well. So what are bases? Bases are those substances which will release OH negative in presence of water. Similarly, strong bases, weak bases. Similarly, you can take the properties of bases, reactions of bases, etc. After that, there is a scale that is named as pH scale. pH means power of hydrogen. Power of hydrogen. So you can say P for potenge. Potenge means power. P for power. P for pushansh. Pushansh means in Hindi we can say that is Shakti. Okay. So power of hydrogen means pH will measure the pH will tell the value of itself according to the hydrogen ion concentration. If more hydrogen ion concentration, pH value will be less. If less hydrogen ion concentration, pH value will be more. There is a mathematical relationship between pH and H positive. That is, pH is negative logarithm of concentration of H positive ion. In simple words, you can say pH is inversely proportional to concentration of H positive ion. In simple words, you can say pH is inversely proportional to acidic nature, acidic strength or acidic nature. In another words, you can say pH is directly proportional to basic strength. pH is directly proportional to basic strength. So actually there is a pH scale at a particular temperature. You can say at standard temperature. There is a pH scale that lie from 0 to 14, but in your higher grades you will learn about, in your class 11th or 12th you will learn that pH values can be vary, right? They can be go up to 13, they can go up to 15 as well. Okay, and according to that neutral point will be decided. So the 7 will be a neutral point. At 7 you can say if the pH value is 7, the substance is said to be neutral in nature. The substance is said to be neutral in nature. If pH value is less than 7, the substance is said to be acidic in nature. If pH value is more than 7, the substance is said to be basic in nature. If the substance is acidic, pH value is less than 7. If the substance is basic, pH value is greater than 7. Now listen me very carefully. If you are moving from 7 to 0, it means from center point to left side. 7 to 0, pH value decreases and acidic strength increases. So if you are moving 7 to 0, acidic strength increases. Acidic strength increases. If you are moving from 7 to 14, acidic strength decreases. Or you can say basic strength increases. Basic strength increases. It means you can say if you are moving 7 to 0, concentration of H positive ion increasing and concentration of OH negative ion decreases. So you can say in the region of 0 to 7, in the region of 0 to 7, the concentration of H positive ion is more than the concentration of OH negative ion. Similarly, in the region of 7 to 14, the concentration of OH negative ion is more than the concentration of H positive ion. And at 7, if I will talk about the concentration, so concentration of H positive ion becomes equal to the concentration of OH negative ion. It means the substance is not acidic, not basic, it is neutral in nature. It is neutral in nature. I hope so far this point is clear to you, right? Apart from this, there is a scale like this. You can draw a scale like this. In this above region, this is like for concentration H positive, and this is like suppose 7. So you can take the concentration of H positive is decreasing if you are moving from this point to this point, and this region is for concentration of OH negative, which is maximum here and minimum here. So this is about some pH. After pH, after acid and bases, let's move to salts. So we had discussed some salts as well. Like in salts, I'm not going with the preparation part. I'm just telling you the names. Like common salt we had discussed, related to Dandi March. Then we had discussed what, like baking soda, baking powder, common salt formula is NaCl, baking soda is NaHCO3, sodium hydrogen carbonate. And when sodium hydrogen carbonate comes in contact with any edible acid, it will become baking powder. Right? Apart from common salt, baking soda, baking powder, like electrolysis of brine, we had discussed about the electrolysis of brine. In electrolysis of brine, you know very well, we will get NaOH, Cl2 and H2, and uses of NaOH, Cl2 and H2. Then you know POP is also here, plaster of Paris. Gypsum is also here, gypsum. POP formula is calcium sulfate hemihydrate. Plaster of Paris gypsum formula is calcium sulfate dihydrate. Okay, calcium sulfate dihydrate. So these are some salts. And one more salt we had discussed before gypsum, before POP. After baking soda, we had discussed about bleaching powder as well. Bleaching powder, which is nothing that is calcium oxychloride. So these are some salts. And before these salts, we had discussed what is the importance of pH in our daily life. What is the importance of pH in our daily life? These points we had discussed in the theory classes. So now I want to move to the NCERT exercise, because now you are aware what are the topics that we had discussed already, and this is an overview of this chapter, that is acid, bases and salts. Okay, so let's move to the chapter now, and let's move to the exercise first question. So you can see the first question is saying that, you know very well, I told you already about the pH scale, right? So solution turns red litmus blue if litmus paper, which is like obtained from a plant named as lichen, which is obtained from a plant named as lichen. And the question is saying that a solution turns red litmus blue, its pH is likely to be what? If the solution is turning red litmus blue, you know very well there are like two types of litmus paper. One is blue litmus paper, another is red litmus paper. If blue litmus paper we have, and another is red litmus paper, blue litmus paper becomes red, blue becomes red in presence of what? Acids. And red becomes blue in presence of what? Bases. In presence of bases. Now the point to understand is, blue remains blue in presence of bases, and red remains red in presence of acid. If red is changing itself from red to blue, then definitely it will be a base. It comes in contact with a base and it is dipped in a base, you can say like this. So solution turns red litmus to blue, you can say solution is basic in nature. So its pH is likely to be what? Its pH is likely to be 1, 4, 5 or 10. You know very well, you know the pH scale. So in pH scale 0 to 14 values are there. At 7 it is neutral, and you know very well, at 7 we can say it is neutral. I am drawing that. This is 0, this is 14. At 7 it is said to be neutral. 7 to 14, concentration of OH negative ion is more than that the concentration of OH negative ion is more than that the concentration of H positive. It means 7 to 14 is basic region. When you move 7 to 14, it means center point to right side, definitely basic strength increases, concentration of OH negative ion increases. And similarly 7 to 0, concentration of H positive is more than the concentration of OH negative. It means 0 to 7 is acidic region and 7 to 14 is basic region. So 1 lie between 0 and 7, 4 lie between 0 and 7, 5 lie between 0 and 7. This is 1, this is 4, this is 5. So this is the, these three pH are from acidic region. And 10, definitely 10 lies here. So 10 is lying in basic region. 10 lying in basic region. So what we can say here, that a solution turns red litmus to blue, its pH is likely to be 1. No, it's 10. Why it's 10? Because basic solution can turn red litmus to blue. In presence of acids, red litmus paper remains red. I hope you are getting this point. So question number 1, answer is D. Basis turns red litmus blue and acid turns blue litmus red. Apart from this, a universal indicator is here, right? And when universal indicator comes in contact with a neutral substance, the color of universal indicator is like green color, right? And similarly, reddish color will appear, not completely reddish, like reddish range will appear if you will move towards the acidic substances and pH will be getting lower. And if you are moving towards the basic substances and strong bases, basicity will increase. Definitely what happens, the color appearance will be different in when the basic substance or acidic substance comes in contact with the universal indicator. So in basic region, universal indicator show like purple range color, or in acidic region, universal indicator show like reddish region or red region. Okay, red region means red shade. Okay, like pink, red, orange, and like that. Okay, so basis turns red litmus to blue, and acid turns blue litmus to red. So basic solution has a pH value more than 7. As we know very well, pH is greater than 7. It is a basic solution. Since the solution turns red litmus to blue, its pH is likely to be greater than 7, which is only a single value, which is 10. So question number 1, answer D is the correct answer. Let's move to the question number 2. I hope you are very much clear. How can we write the answer of these questions and how can we solve these questions? Question is saying that a solution react with crushed eggshell. Eggshell means eggshell contains calcium carbonate. Question is saying that a solution reacts with crushed eggshells to give a gas. Okay, that turns lime water milky. Lime water turns milky. It means lime water is nothing that is aqueous calcium hydroxide, and when CO2 gas is passed through this aqueous calcium hydroxide, you will get what? You will get calcium carbonate. You will get calcium carbonate. Definitely. So, due to the formation of this calcium carbonate and precipitate of calcium carbonate, actually white PPT, the milkiness will appear. Right? The white PPT, due to the formation of this is a base plus and CO2 is acidic in nature. So, base plus acid gives salt and water. Salt and water. The point is here, like milkiness will appear. Milkiness will appear. If milkiness will appear due to the formation of calcium carbonate, also I want to tell you one more important thing. If you will pass excess of CO2, if you will pass excess of CO2, because this calcium carbonate is insoluble in water, and these are white precipitates insoluble in water. So definitely what happens, these are insoluble in water, so tell me milkiness will appear. If you are adding excess of CO2, what will happen? Due to the formation of calcium hydrogen carbonate, which is soluble in water, soluble in water, because it is soluble in water, the solution will again becomes transparent or clear. Okay, so milkiness will be disappear. So a solution react with crushed eggshells. Okay, a solution is here, and crushed eggshell contains CaCO3, calcium carbonate, to give a gas that turns lime water milky. Calcium carbonate reacts with what? That turns lime water milky. So calcium carbonate upon heating will provide a gas, that is CO2 gas, and this is metal carbonate, right? There is one more reaction apart from this heating. When metal carbonate react with an acid, they will form salt, water, and CO2 gas. It means definitely we need an acid. Acid is HCl here because NaCl is salt, LiCl is salt, KCl is also not the answer. So what should be the correct answer? That is option B. Why option B? Because metal carbonate or bicarbonate when react with an acid, they will form salt, water and carbon dioxide. So when calcium carbonate react with an acid, which is an HCl, hydrochloric acid, strong acid, it will form salt, calcium chloride, plus water, H2O, plus CO2. I am not balancing this because you know very well what is a balanced chemical equation and how can we balance any unbalanced chemical equation by using hit and trial method. You have to follow the law of conservation of mass. It means the total number of atoms of each and every element in the reactant side must be equal to the total number of atoms of each and every element in the product side. It means you can say matter can neither be created nor be destroyed. So the equations which are following the law of conservation of mass are known as balanced chemical equations, and the equations which are not following the law of conservation of mass are known as unbalanced chemical equations. Okay, so the correct answer should be option B. Let's see the answer. The answer is option B. The solution contain HCl. Definitely. Let's move to the question number 3. I hope you are ready for this question number 3. Question number 3 is a very simple and easy question. Question number 3 is saying that 10 ml of a solution of NaOH. So we have a base, and this is a strong base, sodium hydroxide, having pH nearly 14. Okay, is found to be completely neutralized, okay, by 8 ml of a given solution of HCl. HCl is also what? Strong acid. You know very well neutralization reaction. So when acid plus base react with each other, they will form salt and water. Acid is HCl, base is NaOH. They will form NaCl plus H2O. Okay. This is strong acid. This is strong base. So they will form neutral salt plus water. Now you can read the question. If we take 20 ml of the same solution of NaOH, the amount of HCl solution, the same solution as before required to neutralize it will be. So you can see here, acid, if I will take 10 ml NaOH, which is neutralized by 8 ml HCl. Okay. If 10 ml required, 8 ml HCl. So if I am doubling the volume of this NaOH, which is 20 ml this time, so definitely volume of HCl required, definitely it will be get doubled. It means we need 16 ml of HCl solution. If we triple it, so we need triple amount of HCl. If I will multiply this 10 with 10, so you have to multiply this 8 with also 10. That particular volumes will be required to neutralize each other. I hope you are getting this point. So if we are doubling the volume, then you have to double the volume of HCl as well. So the correct answer 4, 8, 12 or 16. 16 is the correct answer. The option D is the correct answer for this particular question, because 16 ml of HCl solution will be required to neutralize the NaOH and they will form salt and water. Both are strong, so definitely the salt will be neutral. So let's move to the next question, which is next. Which one of the following types of medicines is used for treating indigestion? Indigestion, when you are taking a lot of food, like a lot of food, acidity will happen. Lot of food, like you are taking sugary items, you are eating so many chocolates, you are eating so many white sugar, right, in different types of foods. Apart from this, you are taking lot of fast food, so food will cause acidity. So acidity will happen in our stomach. It is like indigestion, you can say indigestion. So what we can use to remove that acidity, to neutralize that acidity, definitely we need a base. And base is, if we are saying base, so we can say that is an antacid in terms of medicinal chemistry. Bases are like, we need mild base to neutralize. If you will take strong base, it is not going to be good for your health. Okay, so you need mild base and a proper composition and a proper concentration. Okay, so don't ever take uh, by itself, always take prescription from doctor. Let's understand each and every point. Antibiotics are those medicines which are used to which are used against the bacterial infections. Okay, which are used against the bacterial infection. So this is not the answer, because we need for acidity, we need for acidity. Okay, okay. So analgesics are those category of drugs which are used in severe pain, right, to relieve the pain, to get relief from pain, like headache, severe headache. Antacids, as the name is suggesting, that they are opposite of acids, that means they are basic in nature. Antacids are basic in nature, and actually they are mild bases, and they are used to neutralize the excess of acidity in our stomach. They are used to treat this indigestion part. Like magnesium hydroxide, you can use magnesium hydroxide. Not only magnesium hydroxide, you can use like baking soda as well. These substances are basic in nature. Okay, these substances are mild basic. What about antiseptic? Antiseptic is also used to what type of infection? Antiseptic is also used to stop the infections. Antiseptic and disinfectant. Okay, to stop the what I can say, infection. So A, B, and D are not the correct answer. To cure acidity, to cure this indigestion, we have to use antacids. Like you can see magnesium hydroxide, you can see baking soda. Baking soda is nothing, that is what you can say for baking soda, that is NaHCO3. NaSCO3. So question number C is the correct question number for this question number. Answer is C. That is antacids is used for treating indigestion. Antacid is used for treating indigestion. If you will take any type of acid and that will react, suppose you are taking MgOH also as magnesium hydroxide and it is reacting with HCl, so you will get MgCl to salt and water. This is magnesium hydroxide, mild base. This is an acid. So base plus acid gives salt and water. Salt and water. Let's move to the next question. That next question is write word equation and then balanced equations. So you know, in the first chapter we had introduced how can we balance any unbalanced chemical equation, how can we balance any skeletal equation. So first of all you have to write the word equations, then write the balanced equations for the reactions taking place when dilute sulfuric acid, you know dilute sulfuric acid is nothing, that is H2SO4, reacts with zinc granules. So dilute sulfuric acid and zinc granules is zinc, or you can say Zn solid, reacting with dilute H2SO4. So metal plus acid gives salt and hydrogen gas. So you will get salt, which is ZnSO4, along with the release of hydrogen gas. You know very well, hydrogen gas is tested by what? Pop sound. When you are bringing any burning matchstick or burning candle near the mouth of the test tube from which hydrogen gas is coming out, so you will hear the pop sound. You will hear the pop sound. So this is the answer of this particular question. I will show you the proper answer, but I am just what exposing the answer. Dilute HCl, which is dilute hydrochloric acid, reacts with magnesium ribbon. When dilute HCl, again metal plus acid gives salt MgCl2. I'm not balancing this right now, plus hydrogen gas. Dilute sulfuric acid react with aluminum powder. Same aluminum with dilute H2SO4 will form aluminum sulfate. We know balancing, right? So you can practice the balancing part here. You can balance each and every reaction plus hydrogen gas. Dilute hydrochloric acid with iron fillings. Similarly, metal plus acid gives salt and water. So let's see the solution of this particular question. For part A, sulfuric acid, which is H2SO4 aqueous, dilute sulfuric acid, you can say zinc is zinc solid. You will get zinc sulfate, that is ZnSO4 plus ZnSO4 aqueous and plus hydrogen gas. Hydrogen gas can be tested by, again I am saying, by pop sound. Next is hydrochloric acid plus magnesium ribbon. Hydrochloric acid plus magnesium ribbon. So magnesium plus hydrochloric acid gives magnesium chloride plus hydrogen gas. So 2HCl aqueous. This is the complete balanced chemical equation. This is the complete balanced chemical equation. 2HCl aqueous plus Mg solid gives MgCl2 aqueous plus hydrogen gas. So this is magnesium chloride, which is so hydrochloric acid plus magnesium gives magnesium chloride plus hydrogen gas. Part C, sulfuric acid, which is H2SO4, reacting with aluminium, it will form aluminium sulfate plus hydrogen gas. So 3H2SO4 plus 2Al gives Al2SO4 whole thrice plus 3H2. So this is a complete balanced chemical equation. So unbalanced chemical equation of this particular statement is H2SO4 plus Al gives Al2SO4 whole thrice and 3H2. Okay. Next is hydrochloric acid plus iron give ferric chloride plus hydrogen gas. So hydrochloric acid is HCl, iron is Fe, ferric chloride is FeCl3 plus 3H2, which is an hydrogen gas. So this is the complete balanced chemical equation. HCl 6 molecules plus 2Fe gives 2FeCl3 plus 3H2 gas. 2 molecules of ferric chloride plus 3H2 gas. Okay, 2 molecules of ferric chloride plus 3 molecules of hydrogen gas. I hope you are very much clear about this. So let's move to the next point. Next question is very simple question. I hope the previous question is clear to everyone. Suppose you want to balance this. So HCl metal reacting with dilute HCl, you will get ferric chloride FeCl3 plus hydrogen gas. Again you have to write the skeletal equation, then make a proper table, write down the number of atoms of each and every element present in the reactant side and product side, then use the hit and trial method and then balancing that. Okay, then balance. So you can see here are elements I am showing only for this reactant side how many number of atoms, and product side how many number of atoms are there of those reactants, Fe, H and Cl. So left and right, that means reactant side and product side, both side, the number of atoms of iron atom is 1. Hydrogen, both side, reactant side 1, product side 2. Chlorine, reactant side 1 and product side 3. So how can you balance this? If you want to balance chlorine, so you have to multiply with 3 here. So in front of HCl we have to put 3. If you are putting 3 here, so I am just changing, I am just modifying this tabular form. You have to make the tabular form again and again, okay? According to the number of questions, according to the question, like how many marks are provided to that particular question. Say 5 marks question, so make some tables, okay? 3. Then if you are changing here, so what will happen? Actually now hydrogen becomes not 1, it becomes 3. So hydrogen, to balance hydrogens you have to multiply with 2 here and with 3 here, so it will get 6 or it will get 6. That means you have to put 6 here, so and you have to put 3 here. Now hydrogens are balanced. If hydrogen are balanced, now chlorines are unbalanced. So 6 chlorine, you have to put 2 here, so multiply with 2 here. Now the chlorine becomes 6, multiply with 2, you will get 6, and you have to put 2 here because now the product side will be 2, so you have to multiply with 2 in front of reactant side. So 2Fe plus 6HCl gives 2FeCl3 plus 3H2. You can see 2Fe plus 6HCl gives 2FeCl3 plus 3H2. So this is the answer of this particular question. Let's move to the next question, which is saying that compounds such as alcohols and glucose also contain hydrogen. Alcohol's general representation is ROH. For example, CH3OH methanol containing hydrogen. Glucose general formula, not general formula, glucose formula is C6H12O6 containing hydrogen, but are not categorized as acids. Describes an activity to prove it. This is very simple. Let's take 3 beakers. Make a setup, connect negative positive plates, and connect these plates with battery. Suppose this is connected to positive, this is connected to negative. Okay, this is positive and this is connected to negative. And let's take the solution of, let's take the solution, acidic solution, any acid, acidic solution. Next time same setup, exactly same. Same setup, and take glucose solution, and next time alcohols, here are alcohols. So you can see here compounds such as alcohols and glucose contain hydrogen but are not categorized as acids because they are not providing H positive ions. They are not providing H positive ions. But like acidic solution, they can provide H positive ions and they can be an acids. They can be acids. So 2 nails are fitted on a cork and are kept it in a 100 ml beaker. You can do this another experiment. 2 nails are fitted on a cork and are kept in a 100 ml beaker. The nails are then connected to the 2 terminals of 6-volt battery through a bulb and switch. Some dilute HCl is poured in the beaker and current is switched on. It's like this. 2 nails, as I told you already, kept in a 100 ml beaker. This is 100 ml beaker connected with a 6-volt battery. 6-volt battery connected with a 6-volt battery so that we can pass the electricity. And some dilute HCl is poured in the beaker and thus current is switched on. The same experiment is then performed with glucose solution and alcohol solution. So the HCl solution can pass the electricity, but glucose solution and alcohol solution do not pass the electricity. So this is about the answer of this particular question. I hope you are getting this, that glucose and alcohols do not provide H positive ions or do not provide ions. Do not provide ions. Okay, do not provide ions so that they cannot pass electricity. So reason, Compounds such as alcohols and glucose also contain hydrogen but are not categorized as acids. So I am not saying that they cannot pass electricity. I am just saying they are not acids. Glucose and alcohols, they are not considered as acids. But in your next or higher grades about alcohols, you will understand some important and deep points, but I am not discussing those points. Okay, so for your grade you can say that if I will put any solution, okay, which contain hydrogen, for example HCl, so it is known as acidic solution, because H positive, it will provide H positive while in presence of water. But glucose and alcohols do not provide H positive in presence of water, so they are not considered as acids. I hope this question is clear to everyone. So the correct answer of this particular question is definitely, you can see here, you can use this activity as well. Two nails are fitted on a cork and are kept in a 100 ml beaker. The nails are then connected to two terminals of the 6-volt battery through a bulb and switch. Okay, some dilute HCl is poured in the beaker and current is switched on. So definitely current will passed, and the same experiment then performed with glucose solution and alcohol solution, but then current is not passed. Okay, because in case of HCl, H positive ions are there, so it is acidic in nature, but in case of glucose solution and alcohol solution, no H positive ions will be there, so it is not an acidic. These are not an acidic solution. Okay, so after this we will discuss the another questions in the next class. So far I hope you are everyone clear about the concepts. We had revised whatever we have done in the theory classes, and we had practiced some important exam point of view questions. Okay, so thank you so much everyone. Have a nice day, great day. See you in the next class very soon.